Warning: this experiment uses highly corrosive chemicals and produces toxic gases. This should be performed with gloves in a fume hood. Greetings, fellow nerds. In a previous video, I dissolved platinum into Aqua Regia. Click here if you haven't seen it yet. In this video, I'll be processing the crude platinum solution from that reaction into purified chloroplatinic acid. First, we need to concentrate the crude platinum solution. You can do this by heated evaporation or by boiling. But if you boil, you should cover the beaker with an empty round-bottomed flask to prevent splashing out of the valuable platinum solution. Anyway, since we started with a 31.1 gram platinum bar, we concentrate the solution down to less than 100 milliliters. Once it's down, turn off the heating and let it cool back down to room temperature. Okay, back again. Now we add an equal volume of hydrochloric acid and gently heat the mixture while covered with an empty flask to prevent splashouts. Do not add the acid while hot or it might boil over. Any leftover nitric acid from the Aqua Regia will react with the hydrochloric acid to produce a combination of nitrogen dioxide, nitrosyl chloride, chlorine, and nitrogen monoxide. Originally, these were unwanted side reactions when dissolving the platinum, but now we're taking advantage of them to destroy residual nitric acid. The brown gas forming shows nitric acid is still present. Keep boiling as long as you see it. If the mixture gets below 100 milliliters, then turn off the heating and allow it to cool. Then top it up with another 100 milliliters of concentrated hydrochloric acid. Restart the heating and keep going. When all the nitric acid is destroyed, the vapor will be clear. Looks like all the residual nitric acid is destroyed, but I'm going to give it one more hydrochloric acid treatment just to make sure. Okay, confirm the nitric acid is gone. Now once again, boil it or evaporate it to concentrate it, but this time go down to 50 milliliters. Then turn off the heating and let it evaporate normally at room temperature. We can't heat it dry because it decomposes into insoluble platinum chlorides. If it's not drying at room temperature on air, you might need to use the desiccator bag I showed you in a previous video. Personally, I'm using a professional vacuum desiccator. Here we are with the dried chloroplatinic acid. Break it up and transfer to vials. And here we have nice chunks of the purified chloroplatinic acid. As always, be sure to label your vials. Now, chloroplatinic acid has the extremely annoying property that it's highly hygroscopic. You can see the beaker and bits of chloroplatinic acid getting wetter and wetter as it absorbs water from the air. In between uses, I recommend storing the vials in a desiccator while they are slightly open to keep the contents dry. Anyway, that is purified lab-grade chloroplatinic acid. This is a useful precursor to other platinum compounds I'll be showing in later videos. Thanks for watching. Please subscribe, like, and comment. In this video, we're going to dissolve platinum in a combination of nitric and hydrochloric acids, better known as Aqua Regia. In this video, we're going to examine the chemical resistance of platinum.